All right, everyone. So in this video, I'm going to show you how to graph rational functions. But before we graph them, we want to talk about what is their domain, intercepts, and then vertical and horizontal asymptotes. So those are the 4 things that we must write down for any given rational functions before you get into sketching them. So take a look at this function we have. So say we have some rational function r of x, which is equal to 2x squared plus 7x minus 4 all over x squared plus x minus 2. So here's a rational function where you have a polynomial over a polynomial. Now, first thing you want to decide is what's the domain of this function? So to figure out the domain, of course, we're going to take the denominator, set it to 0, and those are the x values we're going to remove from the domain because that's when the denominator is 0. So let's figure out the domain of this function. So we simply take the denominator, which is x squared plus x minus 2, set it equal to 0. We want to see when is the denominator equal to 0. Now you probably want to factor this quadratic. If it's not factorial, then feel free to use the quadratic formula. So this can be factored into x plus 2 and x minus 1. Okay, and now if I set each factors to 0, I get x is equal to -2 and 1. So these are the points that will make the denominator equal to 0, so they are not in the domain. So if you draw the real line, you have -2 here, open circle, and 1 here, open circle, and everything else makes sense for this given function. So in interval notation, we will say the domain of this function is -∞ to -2, open union -2 to 1, open union 1 to infinity. So that is the domain of this function. Now, these points that we remove from the domain, they actually represent vertical asymptotes. Vertical asymptotes are the x values when the function is undefined. These are the points when the function is undefined. So we know the vertical asymptote, let's call it VA, they are going to be x equals -2 and x equals 1. All right, so we have that. Now, what about the horizontal asymptote? We call them HA. Now, those are pretty much you compare the degrees of the top function over the bottom function. So the top function, I have a degree 2, and the bottom function, it is also degree 2. So your horizontal asymptote, if the degrees are the same, then it's the coefficient of those leading term. So the coefficient of x squared is 2 on top, and coefficient of x squared on the bottom, you can say it's a 1. So your horizontal asymptote is their ratio, so that would be 2 over 1, or simply 2. So that is our horizontal asymptote. Now, if you do need help with that a little bit more, I do have an additional video that explains vertical and horizontal asymptote. I'll link that below so that way you guys can watch it later. Okay, so we got the asymptotes. We're almost ready to graph this function, but next thing I want to find is the x and y intercepts. So let's go ahead and find them. So for x-intercept, we're going to set r of x to 0 because that is your y values. So if I do that, we get, take the function and set the top equal to 0. We have 0 is equal to 2x squared plus 7x minus 4. And now you try to factor this so that way we can find our x-intercepts. We can again factor this by using the AC method, which again, if you need help, there'll be another link in the below description box so you can check it out. This can be factored by using AC method as 2x minus 1, and we can also use x plus 4. So these are the factors, I believe, for this function. Okay, now we set each of them to 0, so we have 2x minus 1 equals 0, and we have x plus 4 equals to 0. So this will give us x equals -4, and this gives us x equals 1/2. So we have two x-intercepts. We have -4, 0, and we have 1/2, 0. Now, lastly, we're going to find the y-intercept. Now, y-intercept is easier than finding the x-intercept because you're simply going to set now x equal to 0. If we set x equal to 0 into the original equation, so if I set x equal to 0, so let me go ahead and copy this function so that way we don't have to keep coming back and forth. So I am going to set x equal to 0 in this function. So that gives me the following. So we're looking for r evaluated at 0. So that'd be 2 times 0 squared plus 7 times 0 minus 4 all over 0 squared plus 0 minus 2. Now, of course, this goes to 0, this goes to 0, this is 0, this is 0. So the only thing we're left with is -4 over -2, which is simply a +2. So our y-intercept happens to be 0, 2. Okay, so now we're ready to sketch this function. Putting all of this together on the xy plane, we will come up with the graph. So let's take a look at how the graph looks like. So I'm going to start drawing the xy plane. So here's our xy plane. And we have, so we have vertical asymptotes. So these are vertical dotted line at -2 and 1. So let's suppose this is -2. So this will be the vertical asymptote. You indicate them by drawing dotted line. Oh, sorry, it looks a little tilted. Let's do it again. Should be straight, vertical line. So there you go. So that is x equals -2. And we also had x equals 1. Let's suppose that's right here. So here's the vertical asymptote at x equals 1. Now, this function also happened to have a horizontal asymptote at 2. So y equals 2. Let's suppose this is y equals 2. So horizontal asymptote will be a horizontal dotted line, something like this. And now, so you pretty much have 3 different separation of this plane. So if you go from left to right, the graph could be here or here. And then the next region we have is either here or here. So 2 regions there and 1 here or here. So you have 3 separate regions. So we're going to go from left to right. So focus on either here or here. So we found a x-intercept to be -4, 0 and 1/2, 0. So let me plot them so it's more clear. -4 is here. That's an x-intercept. And 1/2 is right here. So that was the other x-intercept. And then we also had a y-intercept of right here, 0, 2. So that happens to be our horizontal asymptote. So we're actually going to cut through the asymptote. And that's okay. It's okay to cut through a horizontal asymptote, but it's not okay to pass through a vertical asymptote because that's where the function is undefined. So it wouldn't make sense to cut through them. So now so from this region here or here, the graph has to be below, not above, because it has to pass through the x-intercept. So our graph has to look something like this. So it gets closer to the horizontal asymptote, and on this side, it's going to get closer to the vertical asymptote. Something like that. Now, the reason the curve is that way instead of this way is because we have to pass through the x-intercept. So that's being explained. Now, for the middle segment, it could be here or here. But of course, because there is an intercept, we must pass through the intercept. So we know the graph has to be passing through this point. So it's going to get closer to the asymptote. And then here it's going to catch up with the other intercept. And now you have option. You can either go down or you can continue to go up. So the reason we're going to continue to go up, not this one, because there is no other intercept. If there was another x-intercept that was, say right here, then we would definitely come through it. But because we didn't find another x-intercept other than 1/2 and -4, we're actually going to go above and just get closer to the asymptote. So it will look something like that. Now let me just resketch that so that way it is clear what's going on. So it's going to behave something like this. Okay, so passing through 1/2, yeah. And the last piece, now we have to decide, is the graph going to be like this or will it be something like this? Now again, you can use your best judgment because we didn't find an intercept. That means it has to be up here. I hope that makes sense. That's why intercepts are very helpful to determine the behavior of the graph. Now, if you're not sure if the graph was actually this way, you can always pick a number and plug it into your original function. So say, for instance, I want to verify that is the point the function, that is the point that the graph will go through. So I can select a point. So say something greater than 1, let's say 4. I can select a point within that interval, plug it into the function, and you will see that the y value of that function will be above 2. So it'll be somewhere up here. And that way, you know, it curves in that direction, not down here, because then you'll get something below 2, which is the horizontal asymptote. So I hope that makes sense. Pretty much that is the graph of this rational function. All right, so I hope this helps. I'll see you guys next time. Take care.